Good morning. Today we are going to see about the introduction for algorithms, and we are going to talk about data structures here. Initially, what are the basics of data structures? That is what we are going to learn in this presentation. Moving on to the next slide, the first slide. Actually, first you're going to call computer science as a study of algorithms. When you're going to call computer science as a study of algorithms, then you will be considering all these aspects. The first one is machines for executing algorithms. Suppose if you are writing an algorithm, you need some physical machine to execute an algorithm. Starting from a pocket calculator to a big a PC, you should need some physical machine to write a program or an algorithm. Okay, there are various machine fabrications and organizations, and you have to write effective algorithms through that. The second one is languages for describing algorithms. Okay, the language is actually the system, that is, you have to write the constructs of the language. That is, the constructs of the commands and the translation, how you're going to convert it into a basic set of commands. All these things constitute the languages for describing the algorithms what you're going to write. And then the next one is foundation of algorithms. Foundation of algorithms indicate that you're going to formulate minimum number of operations necessary for the algorithm to perform a certain function. Yet it should be minimum. The number of operations you're going to carry out in the algorithm should be minimum. That is foundation of the algorithms. How you're going to follow. For examples, you will be using abstract models. Then the last one is analysis of algorithm. Analysis of algorithm is actually you're going to evaluate what is the how your algorithm actually works in terms of space complexity and in terms of time complexity. Space complexity, what how many lines of code. LOC is actually lines of code. Actually your program should have minimum number of lines of code, and it should execute faster so that it satisfies the performance analysis. The next one is you're going to learn about algorithm. You're already called that computer science is a study of algorithms. You're going to learn about algorithm. Algorithm is nothing but a finite set of instructions. This is the definition of it. Algorithm is a finite set of instructions if which if followed accomplishes a particular task. And these are the characteristics of an algorithm. It should have an input, it should have an output, it should be definite, it should be finite, and it should be effective. At least input means you're going to give supply some input. Either it will be zero input, or it may be some input 1 2, or it is given externally. Then at least the output is actually, it should give a feasible solution. The output should be feasible, it should be optimum. At least one quantity will should you should get from the execution of the algorithm. The next one is definiteness. It should be definite. Each and every instructions that you're going to give for an algorithm should be clear and unique. And the next one is finiteness. The algorithm should be having finite number of steps, and it should terminate after uh, the condition has been attained. The next one is effectiveness. The results what you have got should be definite, it should be feasible, it should be optimum. That is actually the output should be optimum, and it should be feasible. Actually, then first you learned this computer science is study of algorithm. Later you're going to tell computer science is study of data. Machines, actually you're going to use machines to store data, that is holding the data. Then the languages, for you have to go for languages for describing some data manipulation. And then the structures for representing data, all these things you should be able to carry it out when you're going to call computer science as a study of data. Then you're going to learn about the introduction. Further you're going on, data structure and algorithm should be considered as you're going to consider data structure and algorithm as a single unit, so that one is dependent on the other. You cannot separate data structure and algorithm as separate. You should be considered as a single unit. Okay, then you're having for example, a directory will be having a name and it will be having its corresponding phone number. Okay, this is actually one is data structure and the other one is the algorithm. One will be dependent on the other. Okay, this is a list of n pairs of algorithms. And then data type. A data type refers to a kind of data that variables may store in a programming language. Suppose if you are going to store anything, you're going to use a data type. Actually, data object is actually, it is a term referring, it is referring to a set of elements. For examples, it may be an integer, or it may be finite, or it may be infinite, and you're going to represent some elements in our computer. Okay, that is classification. Generally data structure is classified into two types. One is linear, the other one is non-linear. Linear data structures and non-linear data structures. Linear is further divided into static and dynamic. Okay, under static you'll be learning about array and ordered list. Under dynamic you'll be having linked list, stacks and queues. Further, on the other side, there's non-linear data structures. You'll be learning about trees and graphs. This is the overview classification of a data structure. And then you're going to define something called as a natural number. You're going to define something called as a natural number. And you're here taking a natural number 0, 1, 2. There are three operations which you're going to have, and you're having five functions that has to be defined. That is 0, is 0, and then successor, add, and equals. These are the five operations you're going to perform in this particular thing that is defining a data structure for natural number. 0 is actually a constant function, and is 0 is actually a Boolean function. It will check whether it is a true or false. Successor is actually, it will for example, if you want to depict 3 means you will depict successor of 0. Okay, successor of 0, 0, 1, 2. So successor means the next term. Okay, the next one is add. Add means it is actually a function which is adding two natural numbers. Actually, you'll not be having a number, you'll be using the successor to go to the next term. And then equals. Equals is actually, it will check whether the two natural numbers are equal or not. Going to the natural number series, you're having a structure for natural number, and then you're declaring one constant function, and then you're going to check whether that is 0 is actually a boolean type, where it will be checking whether that particular value is 0 or not. And then successor means successor is actually a natural number, and it will give the output as a natural number. And then the next one is add. Add will get will take two inputs, both are natural numbers 1 and 2, and it will give the result as 3. And then equals is actually, it will be comparing two natural numbers, and if it is true, both numbers are equal, means it will return as true, otherwise it will return as false. Okay, here you are having x and y indicates natural numbers, okay, that you're giving, and you're going to give the semantics. In the semantics, what you're doing here is you're checking 0. You're checking for 0, and if 0 comes, it should return as true. And then is 0. Suppose successor of x is 0, means successor of x will become 1, and you're checking for 0, it will become false. And then the next one, you're adding. What you're adding here, you're adding y is actually a natural number. You're adding one natural number with 0. Okay, suppose you're adding one natural number with 0, the output will be the natural number. 0 is not, it will not, that is what you're indicating in the axioms. And then the next one is actually add successor. Actually, what this is the semantics for adding. How you're going to add two numbers. You're going to represent numbers in terms of successors. And then the next one is equals x comma 0. Suppose you are checking for 0. You are checking for 0 here. If that particular x value is 0, it will return true. Otherwise, it will return false. It will be checking for 0. And then the next one is successor of y. One element is successor of y. Successor of y is actually, you'll be having some number will be there. Successor of y will be having some number, and at the other end you're having 0. If one number is 0 and the other number is something else, obviously it will return as false. And then if successor of 1 is 0, here 1 is 0, the other one is y, here the next term both are successors, successor of x and successor of y. If both are there, then it will be, you're going to check for equality once again. This is actually the data structure for natural number. Then the definition for natural data structure. Data structure is a set of domain. D stands for domain. That is, and small letter d stands for data structure. It is a set of function f and a set of axioms a, and you're going to call DFA indicates actually the data structure. Okay, and it denotes a set of domain, function, and axioms. Totally, you're going to call it as data structure, and you're going to use D is actually the data. You're going to formulate what you're using there. That is natural number. So D stands for data structure. You're going to create a data structure for natural number. D is actually what? D is actually domain. What domain you are using there? That is natural number and Boolean. So you are specifying that. F is actually functions. What are the functions you are using in that particular data structure? That is 0. 0 is a constant function. Is 0 is a checking Boolean function. And then successor will go to the next term. And then add is actually a function which will be adding two numbers. And the equals is actually a Boolean function which will check whether two numbers are equal or not. All these are functions which you are specifying in declare, and A stands for axioms. That is coming in the later part of your structure. Okay, then, and you're going to implement the implementation of a data structure D is mapping from D to a set of other data structures E. You're going to map. Okay, and you're going to use something called as Sparks for easier thing. D stands for domain, F stands for functions, and A stands for axioms. Okay, this is the range of values that the range of values will be domains. The operations will be called as functions, and the axioms is actually the set of rules which can be implemented. Hope you understood. Thank you.